Hi, welcome back. In this video lecture, I will solve problem 17 of chapter 5. Actually, this is the next case of problem 5.16 that I solved in the previous video lecture. The statement of this problem is that if the bullet in problem 5.16 is fired due east at an elevation angle alpha. Actually, in problem 5.16, the bullet was fired vertically upward, but in this case it is fired due east at an elevation angle alpha from the point on earth whose latitude is lambda. Show that it will strike the earth with a lateral deflection given by 4 omega v naught dash cube sine lambda sine square alpha cos alpha over g square. So as per the given condition, the bullet is fired in xz plane, in xz direction with velocity v naught dash. So from the condition, we know that y dash, actually velocity is the velocity component. So y dot dash, it is equal to 0, x dot dash, it is equal to v naught dash cos alpha, then z dot dash, it is equal to v naught dash sin alpha. So this is very simple. The initial position of bullet is origin as it was in the previous case also. So x dash, y dash and z dash, they all are equal to 0. The position of bullet in all three directions, we have to calculate that. So again, in this problem we will use the equations as mentioned in the previous problem. So, and these equations are also mentioned in your book. The equations are 5.4.15a, 5.4.15b and 5.4.15c. So now I will use equation 5.4.15b. so this is the equation y dash t, which is equal to y dot dash t minus omega x dot dash t sine lambda plus y dash. So again, as we did in the previous problem, we will simply put the values of x dash, y dash, x dot, y dot and y dash. So these two are the velocity component, like this one, and this is the position. Okay, and simply we will put these values, and we know that this is 0. I mean we know that this is 0, and the y dot dash, we know that it is equal to this value as mentioned in the previous slide. And yeah, so this term, like y dash, this is the position, it is 0. So after putting the values, y dash t, it will be equal to minus omega dot v dash t square cos alpha sin alpha. So this is equation 1. Now using equation 5.4.15c, z dash t, it is equal to, actually this is the equation, z dash t equal to minus 1 over 2 gt square plus z dot dash t plus omega x dot dash t square cos alpha plus z dash. So again we will put the values of velocity x dot dash, y dot dash and the position z dash in above equation. So after putting the values, actually you know that in the first slide I mentioned the values of x velocity components and the position components. So we will simply took the values from there and we will put here. in this equation. And yeah, this was the equation, and here we just substituted the values. After substituting, we will get z dash t equal to minus 1 over 2 gt square plus v naught, because this z dash we just put the value here, so this was the value. So we have v naught dash sine alpha t plus omega. Again, this is the substituted value, v naught dash cos alpha into t square cos alpha plus 0. So with simplification, we get minus 1 over 2 gt square plus v naught dash sine alpha t plus omega v naught dash t square cos alpha cos lambda. So this is equation 2. At the time when bullet hits the ground, it z dash t should be 0. So equation 2, this is the equation 2, it becomes 0 equal to minus 1 over 2 gt square plus v naught dash sine alpha t plus omega v naught dash t square cos alpha cos lambda. So with simplification we get gt minus here gt minus 2 omega v naught dash cos alpha cos lambda t equals to 2 v naught dash sine alpha. And from here we will get the value of t. So t is equal to 2 v naught sine alpha v naught dash sine alpha over g minus 2 omega v naught dash cos alpha cos lambda. So what we did, we just took the t common from these two terms and then took this part to the right hand side. So the time t, it is equal to 2 v naught dash sine alpha over g. We took this g as a common, and after taking this common, so here we have 1 minus 2 omega over g, so this is omega, and when we take common, so it becomes omega over g v naught dash cos alpha cos lambda. So this is the equation 3. In this equation, the term omega over g, so this term, it is very small when we compare it with the 1, so it is very small, so we will simply ignore it, we will put it as 0. So after ignoring this term, the value of t, it will be equal to 2 v naught dash sine alpha over g 1 minus 0, or t equal to 2 v naught dash sine alpha over g. So this is time t ground. So now checking y dash t at this value of t for lateral direction from equation 1. So yeah, this is the equation 1 that we calculated in this problem. Y dash t equals minus omega dot v naught dash t square cos alpha sine lambda. We will put the value of t simply. This is the value of t that we calculated. We will put in this equation, and after putting the values, you can see this equation. Here we substituted the t here, and with simplification we get y dash t, which is equal to minus omega dot v naught dash dot 4 v naught dash square sine square alpha over g square cos alpha sine lambda. Then y dash t equals minus 4 omega v naught dash cube sine square alpha over g square cos alpha sine lambda. So actually this v naught and this, we just multiply this with this one and it becomes v naught cube. At the time of hitting the ground, the lateral deflection is given by y dash t. So actually I just wanted to show that, yeah, so this term, like this term, it is the lateral deflection, that we wanted to show. It is demanded in the problem. Thank you.